So as you watch this video, we'll be taking a look at how you take the derivative of the natural log function, ln of x. So let's just start off right away with the rule. So the derivative of ln of x is always going to be 1 over x. So as we go forward, that's really not going to be our biggest concern. Our biggest concern is going to be what happens when it's way more involved. So for instance, what happens when I have to take, let's say, the derivative of ln of x to the fourth or something of that nature, right? So what we want to do is we want to look at this idea of what we call a chain rule. And it really is kind of like a chain reaction of derivatives. So the chain rule is used when we have a function that is embedded inside another function. So the way we would look at that here is by looking at x to the fourth, right? So in this problem, we have a function, let's call it u. So u equals x to the fourth. So what that really means is we're looking at ln of u. So when you have situations like this, the derivative of that would be 1 over u, just like it was a minute ago for ln of x. But the difference is u has a derivative that is well beyond just 1. So we have to add on, and this is that chain reaction, the derivative of that embedded function. So for this problem we're doing right here, the derivative would have to be 1 over x to the fourth times 4x cubed. Why did we have to do that before? Well, it's actually kind of simple because the derivative of x is just 1. So multiplying that times 1 wasn't really going to change anything that I got from my derivative. So the thing we have to do now is look at 3 of the examples. These examples are in your notes. We'll show you how we do not only the chain rule with ln, but how we also incorporate it into the product and quotient rules as well. So our first example is y equals x to the 10th times ln of x. So because we have, and let's be clear about this, right, we have 2 different functions, right? Here's one, here's the other. We kind of have that f and g approach where we have a product of 2 things, right? So that's going to involve the product rule. So if you remember, that was f, let's say, times g prime plus g times f prime, right? So what we had done when we initially learned the product rule was we actually wrote some things out. So if we let f equal x to the 10th, then f's derivative is 10x to the 9th. And if we let g equal ln of x, we just saw that g prime is 1 over x. So now it's time to carry out our product rule. So f times g prime plus g times f prime. And as always, if there are opportunities, easy opportunities for you to simplify and reduce, you should. We could definitely do that with this first term. So we're going to say our final answer is going to be x to the 9th plus 10x to the 9th times ln of x. So let's go through 2 other examples. Now in this second example, we start off with y equals a quotient, ln of x, over, and I'm going to write this as x to the 1/2. So we can still do that. We still have that f over g mentality here, right? And if we remember the quotient rule, low d high minus high d low, all over low squared. So you can actually, if you want, go about this the same way we had in the other problem. If f is ln of x, then let's set ourselves up, get that derivative. And if g is x to the 1/2, let's set ourselves up with that one and get 1/2 x to the negative 1/2. Okay, and let's carry out the quotient rule. So low, d high, so g, f prime, right, minus f, g prime, a little ugly there, all over g squared. So we can do just a little bit here, not too much. x to the 1/2 over x to the first. You can subtract powers there, so you can call that x to the negative 1/2. Kind of can't really do too much here, so we'll leave that like that. And actually on the bottom, x to the 1/2 squared is really just x. So we're going to leave our final answer like that. But again, this example is really just to try and show you how we use the chain rule and the quotient rule together. Now, in a final example, this is more like that first screen when we had talked about ln of u. So we have ln of x squared plus 4x. So in this problem, unlike the other two, you have a situation right now where the piece of the puzzle that you're used to seeing as x is way more than x. So we're going to let u equal x squared plus 4x. And the derivative of u is going to be 2x plus 4. So if you remember, when we execute the chain rule here, if we say y prime, it's always 1 over, right? 1 over x. So this would be 1 over what they gave me. But I have to multiply that times the derivative I got when I actually derived this inside piece here. And that was 2x plus 4. And that would be it. So it's actually easier to do than the other two problems, I think. But it's a little different. So what we're looking for is always be mindful of what's inside that log, because we're going to have to derive that. So what you want to do now is there's a group of 3 problems you can practice with the other people in class who are looking at group C. And then you will go back to your respective groups and teach your group how to deal with this log function.